So what I wanted to focus on is if we frame kind of a conversation today on why actions, what it is, and how it is. I'll touch upon why you care, why it's different, what's in it for you. I'll touch a little bit on what it is, and then really turn it over to Ali, Daniel, and Jacob to go deeper into what it is and how you actually use it. Thanks, buddy. So a 10,000-foot view of what it is, I'd like to say if GitHub is a collaboration platform that includes version control, GitHub Actions is really an automation platform that includes CI/CD. Now, when I say automation platform, I mean you can automate any event that comes in or out of GitHub. So it's not limited to push events. It could be anything from pull request, delete, issue, comment, fork, whatever it may be. Ali will get into some of the matrix builds and secret stuff. But what I really think is important is the idea that it is community powered. So what I mean by that is if you understand the notions of open source, the idea of actions, you can use any actions that Arctiq built, you built, any number of the people on the community built. So for example, here, we're talking about how the actions YAML file here is using setup node. So what that means is you don't have to rewrite how to set up node every time you're using an action. All you have to do is point to this action that does that for you, right? And then it simply tells you to use me or to use this action. All you have to say is use this setup node. Now, speaking of node, node itself and the community runs on actions. So this is the node organization and the repo. And on their actions tab, you can see that they're running all of their node builds, or not node builds, but compiling node if we look at some of their tests. Okay, and the takeaway here is it is unified within the GitHub platform, and two, the community is what's powering the ability for you to build it. It's not limited to Node. Arguably, the most popular editor right now runs their CI on Actions. And then lastly, Ruby, the language, is also running their CI/CD on the GitHub Actions platform. So in summary, at a 10,000-foot view, that's what Actions is. Why you care is it's community powered and it's unified within the GitHub platform itself. I'll turn it back over to Ali to continue. Yeah, they're running some actions as we speak on Ubuntu and macOS. But thank you, and I'll turn it back over to Ali to continue the conversation.
Thank you. Perfect. All righty. So generally, when I think of introducing a new tool into an organization, I go through a thought process on how it will impact my productivity, the team's productivity, developer, and ops. And the 4 points I usually come across with a new tool is ease of use, adaptability, maintenance or minimal maintenance, and learning curve. We'll start with ease of use. So I want to map those 4 points to actions, and then we'll go from there. If I have a fantastic new tool and I have a 600-page manual that I need to read, or I have to learn a whole new syntax, it really takes the wind out of my sails for that tool. I have enough to focus on with my actual task. Having to adapt a whole new tool with a whole new syntax is not the most appeasing thing. So the original version of Actions used HCL. The new version now uses a YAML syntax. So depending on who you ask, YAML syntax can be easy to write. However, it's become the de facto in a lot of configuration tools, from Kubernetes to Ansible. It's become the real standard. It's again, flows easy, reads easy. The other great thing with as Mike mentioned with Actions is you can trigger it on any event. So if on your on-prem CI/CD, you usually have to plumb back webhooks for different events. The fact that the code lives parallel to your CI/CD in this sense, you can trigger it on any GitHub event, not just a commit or a pull request. Again, the fact that it's written in plain English, plain YAML, it's easy to reuse, share, and fork code. If you write a solid pipeline in one repository, you can just snap it out, drop it into your next repository, and it's ready to go. We were early adopters. We are early adopters of Actions, and in this iteration, the more time I spent with it, I would think of Actions as Lego blocks. So I'll give you a quick little example. On the left-hand side was one of the first pipelines I was working on. So I have a checkout action, I have a go build and test, I have a Docker action, I have a full GCP pipeline, and then I have a Slack action. I wanted to insert a linting process in there, and all that was necessary was to go to the marketplace, find the correct linting tool I wanted, snap that code out, put it into the appropriate place in the pipeline, fill in the metadata if it needed any. This one didn't, and my pipeline's easily extended. I can now just take that, fork it, do a revision on it, and move it along very easily. So here's a basic example of an action. So we'll get into this. I don't want you to squint at the eye chart, but basically a simple action has a name, an event that it's pushed on, the platform it runs on, and then the steps. All actions generally start with a checkout because you want your code in the build space. And in this particular case, we're running shell commands. You can run Python commands. There's a whole whack of shell you can do, or a whole bunch of containered actions you can do. So adaptability is the next major thing. Many organizations have existing pipelines within their setup. They have Jira integration. They have integration to their other tools. Moving from one platform to another is not necessarily easy. Marketplace, I think, has how many actions? Give it about 1,500 actions, community-driven and made by the vendors themselves. So plenty of actions that you can use to migrate your existing platform into there. Again, from Jira to GKE to AWS, there's a boatload of them. And the other great thing which I wanted to show you later on is matrix workflows. If you're a developer, most of the time in your operational shop, if you have to ask for a Windows machine, a Mac machine, and a Linux machine, all having version 8 and 9 of Node to do your application testing on. Now you come back and you have to ask your operations team for yet another release, for another runtime. That is change requests, operational overhead, a lot of asks from the development operations team. With matrix workflows, you literally just comma append the runtime you want, the operating system you want, and it will span out and do your code build across all the operating systems. I'll show you that in one of our other use cases. And similar to that, simultaneous testing, right? So using the same approach, you can simultaneously test your code on all these platforms. Here's a quick example of doing a Node build on 2 versions of Node. So again, it's rinse and repeat, which makes it really easy for you to extend and expand how you use actions. So in this case, name is CI. On push, I want to do a matrix strategy of using Node 10 and 12 on Ubuntu. I check out my code, I set up Node, and in one go, I install, lint, test, and build across 2 runtimes. Super easy. Again, think of it like Lego blocks, and much easier for developers to kind of test across multiple spans, and minimal interaction or overhead for operations folks. So Actions can work with a boatload of languages. Some of the major ones: Node, Python, Java, Ruby, PHP, Go, Rust, and many more. .NET is also a popular one there, because it has the Windows runtime at the back, so you can also build on your .NET applications. So this is a great little image I wanted to explain. When I see this, I think of development environment as a service. You can literally go into your workflow, just click, and it builds the whole environment out for you. So whether you're a Python developer, Node developer, Go developer, click, and it scaffolds the whole framework down for you. All you have to do is then stack blocks of code that you want to put in, and hit and then trigger the action on the event. Similarly to the CI portion, the CD portion, it has all the major cloud builders in there. So AWS, Azure, GKE. You select the endpoint. You fill in the metadata for that endpoint, and then you can then take your CI portion, drill it down to your CD portion. Super easy. I'll demo all this for you. So quick example of how easy it is on the GKE side. All the syntax is codified. So you fill in your environment variables from your secret store, and that's essentially it. The rest of it will auth your service endpoint, and then you can do whatever you need to do: Docker build, gcloud push, gcloud auth, whatnot. Similarly to the matrix build, you can do matrix build with multiple runtimes on multiple operating systems. So similar to our last Node example, we ran a Node, in this case running on Node 8, 9, and 10, but now we're spreading it across 3 operating systems, so Ubuntu, Windows, and Mac OS. All you have to do is comma append the next runtime or the operating system, and you can test build across multiple platforms. Super easy, minimal overhead. Again, maintenance, all infrastructure is hosted with GitHub, so there's nothing to maintain. All the container platforms, runtimes, they run on GitHub hosted servers. You can focus on developing your code, gain productivity, and for organizations that do need on-prem, there is on-prem runners that we can discuss later on as well. These are the platforms available. So Mac OS, Linux, ARM. Again, runs it. Your actions can either run on a virtual machine platform or within a container. So we have in our use cases, I'll show you a demonstration of doing it using shell code as well as using container runtimes. And you can use your own VMs in the cloud or on-prem if you require. There is a built-in secret store. So I know a lot of organizations use HashiCorp Vault. There is an action for that, so you can always leverage that. But if you do not have a secret store, when you enable actions, you also can enable the secret store, and then it's a one-time write, many-time read. So if you lose it, you can't reveal it. You just have to wipe it, recreate it, and then you can codify a repository code so that you would leverage the secret similar to this. So secret dot, and this would be the name within the secret store that you want to leverage into the code. And the last point before we jump into a demo is learning curve. So best part about this is the true testament to this platform is I spent more time noodling around with the demo itself than I did with building the pipelines. In most of our day-to-day tasks, I mean, we context switch between P1 tickets, emails, rolling out the next feature. So the last thing you really want to do is burden new tech onto someone who has releases to get out or things to get done. So this really does relieve cognitive overload. A bunch of plugins and existing tools. So again, Jira integration, Vault integration, many integrations, and all the major cloud vendors are there. And worst of all, if you're in a gem, you can always roll your own. If you're using containers in your existing CI/CD pipeline, you can always just extract those and roll them into a GK action. So GitHub action. So there's not a huge delta between where you are and where you want to go. Cool. All right, so let's get into our first demo and see this stuff happening. So in this first demo, Mike here is the CTO, our fictitious random Acme Corp. We have two products we serve at this point. They're both random jiffies. So I'll show you the microservice layout. We'll talk about the pipeline. Mike will discuss the feature, and then we'll go through the approach. So give me 1 second. Let me just get changed here. If you have any questions in the meantime, you can fire away.
Is Acme Corp at all correlated to Evil Corp?
It could be, Aaron. It could be. Alrighty. Alright. Okay, so I will actually, let me show you the front end first. So here is our product base on the front end. So we run a 3 microservice product. We have a UI front end, and then we have 2 API parsers on the back end that call Jiffy. They take the data, they break it down. I'll show you the code as well. They break it down, they put it into structs, and they feed it forward into the UI, and the UI marks it up and brings it forward. So let's go down here. All right, so this is our random beer Jiffy. Okay, let's try another one. Alrighty, so there's a random beer Jiffy. Here's another one. There we go. That's a better one. Okay, and here's the same one on the back end. I'm using another microservice. We'll try, see if we get a slightly larger one. There we go. So we can take a look at our pods. We see that we have 3 pods running our beer service, 3 pods running our Simpson service, and 3 pods running our UI service. So after a board meeting, Mike has come back and said the Jiffy thing is getting old. We want to do dad jokes. Mike's a new dad, I'm a new dad, so we're going to do the dad joke here. Okay. So this is the current pipeline that we have, and I'll go through it as it's building, so you get to see it up close. So we check code in, we do a go build test, then we run through a Docker build test, we call GKE, we get our kube config, we upload deployment configs, we roll out the new service, and then we notify ourselves on Slack. So this is the dad joke feature. Essentially, they just have a bunch of really cheesy dad jokes, but they expose an API that allow us to call it, pull it back in a JSON format. We can reconstruct it into a Go struct. Then we can feed that into the UIs where it can mark it up and parse it out. Pretty standard stuff, but it'll show you a good process of feature to release. So this will be our approach. Again, we'll cut the microservice. We'll do a PR. We'll do a first action on pull request. So if in this point it fails, it's going to get blocked on the merge. If it does pass this point, it will allow us to merge to master, and only at that point will it again go through the whole process and then roll out to production. All right, so let's code something. Okay. So I'm going to start a new branch. We'll call this new feature. Oops, sorry. Okay, and for the sake of time, I've packaged the code, but if you guys want to see it, I will break it out here so you can take a look. All right, so for those who are curious, we're running, again, it's a small Go microservice. We're going to be calling the dad joke API backend. It will return a JSON body. We are going to parse that body into a data struct that we can then accept on the front end. And we'll return that a JSON call parsed properly to the UI. It will then ingest it, mark it up, and present it to the front. Okay. So in that, I'm going to rename the old index page because we are going to also update the front end. And because of the way we've built this particular microservice, we're simply going to append a list into the name of the microservice into the list so that we can use shellcode to actually mark it up. In the next release, we'll show you how to do code to software release. Okay, so let's just make sure we have our changes. We have an append here. We remove the old one, add the new one. Yep. Publish branch. Okay, so a new commit is in. We're going to do a pull request. And we'll check out our action. So you can see here, we've broken out different actions for different purposes. So our linting, we wanted to show you that you don't necessarily have to construct everything into one action. Most of the time, linting is for best practicing and how to look for syntax errors in the code. So we wanted to keep that out because it doesn't necessarily mean the code is going to fail. So we wanted to show you that on the same event, you can run an independent action, but you can still run your full core pipeline on the main action. So let's get into this guy. Yeah. Too much? Okay, so we can see it's setting up the job. It's going to actually pull down a couple of our actions. We have an issue creator here. So if there's a failure in the build, it'll create an issue. I can show you that afterwards as well. But it's going to pull down all the prerequisites for the action. So in this case, it's pulling on the Slack notifier. It's pulling on the issue notifier. It will then set up my Go build environment. And then we'll step through the rest of it. And then I'll give you an idea how it looks. So this can take, while it's ramping up, I can show you what the YAML looks like if it helps. So all the actions live in a subfolder within your repository under .github. You can put your templates here, workflows folder, and then simple YAML files. And here essentially is our pipeline. Again, we're testing on Ubuntu, set up Go, check out the code. For Go, we're doing a dependency check, a build test. You can actually apply logic into the steps. So only if there is a failure would you create an issue. If there's a failure, notify Slack of the failure. Otherwise, notify Slack of the success. All right. So while that was happening, so code went in clean. Build test was correct. You can see our new feature was picked up. The 3 original ones are there. So that it didn't have to create an issue or notify Slack of failure, but we should have a Slack notification of success. All right, so build test successful. This should now allow us to merge this pull request. So perfect, new feature is good to go. All the checks pass clean. We can now merge, and this will now trigger the push to prod action. This one's a fair bit larger because we're going through the same steps, but I also have to call GKE, pull my tokens down, update my deployment configs, and push them back out. So I'll step through this one. Actually, if you want, they don't take that long. It'll just rip through for the most part. Let's take a look at that one quickly as well. So for the most part, I mean, the top part is the same. I'll jump down to where it auths Docker, for example. Now, GitHub also has an image registry that you can leverage. It also has a package registry, Mike, I believe, for node packages and whatnot. So, and you can easily access those. All you have to do is use your, I think, the GitHub, your personal access token, your name, your account, like your GitHub ID, and you have access to that as well. In this case, I'm using the Docker registry, so I provide my credentials. I do a Docker auth. So you can see here we have a good mix of using the container actions as well as some of the shell actions. In the GKE actions, I have my GitHub GCP secrets, my project ID, my location, my cluster name, and then I will get back here. Make sure we don't get too far ahead of us. So it's still rolling out. And then we test our deployment config. I have some shell code to update the deployment config, and then we roll it out. I didn't put a failure here on purpose, just because by the time you get to master, you really should have vetted it. This is a toy example, but you can put many stop holes in there to make sure that you're not pushing to anything to master that really shouldn't be there.
So Ali, I'd say just while you're waiting for it to load, if you go back to your YAML file, I kind of touched upon it, but now while we're doing it live, Ali uses machine learning app / GKE kubeconfig, and then uses pull reminder Slack action. So what I mean by that is he doesn't have to rewrite how to trigger a notification in Slack. He just has to point to that action. So I don't know if that's clear how valuable that is as a person that doesn't want to have to rewrite or relearn this every time. So that's how Ali's using building blocks to build actions for it.
That's the thing I was mentioning. That the top part, I didn't go over it again because essentially it's the same. I didn't have to reinvent the wheel. I just stack in the pieces that are new to the pipe. The rest are all the same. So here we're going through our build. After this, we'll go to a push. And this really is where the platform shines, because now if this is a standard template in my organization, once I have this licked, I can just present it to my colleagues, whoever else. It really allows it to go forward. And truth be told, a lot of this is community available. It's not like I reinvented the wheel here. I took pieces that other people had put together, put whatever I needed in, stuck it together, and away it went. You'll see in Daniel's presentation that he does an original action. And that's something that he can then release back. So it really builds on the sense of community and marketplace.
Speaking of marketplace, it may be a good opportunity to go to the marketplace in your YAML file there. If you click on just the top. So when Ali talks about marketplace, on the top of the bar there, and as you can see right within your action, this is actually powered by this. So we're at about 1,500 actions. That's what Ali was referring to when he said how many actions are out there. So the community is like about 40 million people, and those 40 million people have written about 1,500 actions. So what's a technology that somebody here uses? Just call it one.
SonarQube?
SonarQube. So, Ali, if you type in SonarQube here, you'll see that there's a handful of actions that people have written already for Sonar Scanner and what have you. So rather than you have to rewrite that, you can just reuse it. Now, also, if you use it and you find, hey, there's a slightly better way to do this, or I found a mistake in maybe a comment or something, because it's built like community, you can freely suggest that change back in. So as everyone is trying these things out, it kind of gets battle tested by them.
And you can always fork the repo, adjust it as you want it, because it's available there. Adjust it as you see fit for yourself, release it back, whatever you need to do. Okay, perfect. So in that time, we rolled it out. We can see that we had our original pods lined up there, rolled out our config. We should have a Slack notification that we pushed to production. Yeah, successful push to prod. So let's take a look at our perfect. So now we can see there's a new microservice that's been rolled out. Right here, we have our original microservice, and here's the dad joke microservice. So let's go ahead and take a look at the landing page and see. Perfect. So now we have rolled out a new feature. All we have to do was deal with the code. Pipeline took care of everything else. So let's go ahead and see what it has for us. Right? Terrible jokes, right? There you go. All right. So there's a decent example of idea to production. What I'll do now is while we still have you guys going, I'll show you how to go from code to release. So we did code to microservice. So now, let's just say our CTO has come to me and said, you know what, this thing is done really well. There's a market to sell this, or you want to give it to people. I want you to take this back from microservice to monolith and release it as code. So in this next demonstration, I'll show you how matrix building and automated releases work. So all right, so now we're going to go through this approach. Before we did Go modules into individual microservices, out to Kubernetes, and to GKE, now we're going to go from modules to matrix testing to single release. All right, so.
But we're not condoning building monoliths.
No, it's just a demonstration. Okay, so in this particular case, you can see it's just single Go modules, no runtimes. If you look inside them, there's no web service, just a whole bunch of code that that returns a struct back to the main front end. So let's go ahead and do a new. So I'm going to edit this. we're under the assumption here that the module, like the modules already put together. I more want to focus on the matrix operation and the release operation versus the code, because the code's put together. So we'll say adding more comments for this demo. I'm going to create a new branch, new comment in my code. So now when I trigger this, I should probably do a pull request first. Okay, so create a pull request. And now what we're doing is we're triggering 3 builds on here. We're triggering a code build, we're doing a matrix build, and we're doing a linting build. So with linting, again, as you know, it's going to parse the code just to show that you can separate it. But what I want you to see is actually the matrix build. So the matrix build now is going to take my code and simultaneously test it on 2 Ubuntu releases, 2 Mac OSs, and 2 Windows releases. What I'll do after is if you want, I can add another runtime, and you'll see them just scale out and to test across multiple runtimes. So here the matrix build is running. We have a build on PR and a linting process running. So you can see as they check off, so I have logic within my single YAML file that says, because of the way Go is set up, they all have different Go paths. So my Go path in Mac OS versus Windows versus Linux is different. So I've put in logic within the YAML file, which I'll show you, to actually be selective. And so you can use logic within it to actually decide where the code gets executed and how it gets executed. So this goes through the build. So the other thing I've done, because I wanted to show, because as I was learning this, I wanted to put debugging within it, because developers will do that. When I was debugging the Go path, because it was different for each OS, I wanted to throw this in to understand where different components were. So you can do the same. It's essentially just shell code running through the pipeline, super easy. And then we'll take a look at this. So matrix build, all complete. So now I know my code is valid with Go 1.1.2 and 1.1.3 across all the platforms. With the linting, no findings. And with the pull request, build complete. Notification in Slack, package PR build test successful. So we are good to merge. Show all checks. And essentially, that's what you want to see when you're building your code. Now, if you wanted to test this on another on yet another runtime, all you have to do is come back in here, edit this, and now I can test my same code on all the platforms with another runtime. If I had to ask operations for another machine with another runtime, this would have taken me forever. In this case, it's as simple as appending a new runtime onto your code. Okay, so with that done, we now want to go to release. So I have an action here where if I was building on-prem and I had to release to all my operating systems, I would have to set up all those pipelines to do a multi-OS release for multiple builds. With actions, I can set up a release build, and all I have to do is tell it, oh, sorry, all I have to do is tell it, check out my code, here's the Go architecture, here's the platform, build it. I just have to append them on each other. I can easily variabilize this, but I just want you to see what it's capable of and how it can scale. So let's go ahead and do a release. And all I need to do is tell it to watch for release. And we'll do a V, what is it, 0.6. I want to build it off master, publish my release. And when that event fires, now I have a full simultaneous build of my application happening in real time. I don't need to do anything else. I just have to trigger a release, and away it goes and does everything for me. So we'll let that go forth, and then it will do the release. So it'll do the build, it'll do the release, and it will inject it back into my Git repository automatically. There's nothing for me to upload, nothing for me to test. I can do everything within the same pipeline.
Just while watching this tail, another tip or whatever it is. Well, a couple of things. See the blue text? The blue text is what we wrote, and then the white is what is responded back. And two, if Ali clicks on any one of those line numbers and says, hey, Daniel, Jacob, what do you think about this output here? Then you can just send that link so you don't have to kind of go scrolling through the logs and say, you know, oh, go to line 453 right after that. You just click on 453, sends it right away.
Correct. You can also pull down the whole log, save the log, parse it later, view the raw logs. Super easy. So our releases are done. Now if we go into code, releases, I should have 6 releases all ready for our end user to download. So all I had to do was focus on the code. Pipelines took care of everything else. So that's idea to release. Cool. So that's it for me for that one. We can take a little break and then grab a couple drinks, grab some food, and then we'll come back with Jacob with the Terraform as code. Awesome. Thank you.
My name is Jacob, if you guys don't know me. One of the consultants here at Arctiq, mostly focused on a lot of automation and microservices stuff. So for this demo, I'm going to go through a workflow of updating some Terraform code. First branching out, adding some Terraform code to a website, submitting a PR, getting it approved, and then merge it into master, and then that code will get updated on the actual website. So I'm just using, I'll kind of walk through like the environment of what I have stood up. I have a GCP bucket that's just serving some HTML pages. So it's just a static website that I'm using. So this is my demo website, just a food website that I found online. And the idea behind it right now is that if I go to a page that doesn't exist, I get like an ugly error from Google just saying that the file doesn't exist or anything. So what I want to do is I want to be able to, when I do this, I actually get a custom 404 HTML page. So basically all I need to do here is come in, update my Terraform code, submit a PR, get that approved by somebody who's an administrator or something on the repo, and then go ahead and approve that, and that'll get approved automatically into the master branch. So I'll first go through like the pipeline, this diagram that I drew, kind of showing what is going to happen. So someone can come in at the repo and say they want to make that change, that 404 change. So what they can do is they can branch out, add the code that they want, and then submit the PR. I have an action listening on the repo, so for any PR that is submitted, what it'll do is it'll kick off the Terraform plugin that will validate the code, check any formatting issues, and then do like a Terraform plan. That plan, for anyone who's familiar with Terraform code, is what gets sent and is viewed in the PR. So for someone like me who is just checking PRs and wants to approve them, I can just see what's going to change in my Terraform code. And I'll show you what that looks like. I also get a notification with Slack once it's done. So the idea behind that is that I, as like an administrator or someone who's like managing this repository from like an admin level, won't get notified of any changes or any PRs until it's actually approved. So until I know like the code is good and up to like a good standard. Once I get that notification, I can go ahead and check the PR. I can go review it and make sure I agree with the changes or comment back, just like you normally would in a pull request. Once I'm happy with it, I can approve it, and I'll merge the PR to the master branch. Once it gets merged, I also have an action listening on any pushes to master branch, and that will trigger another Terraform plugin to go and apply. I have the action listening on apply to master because I've locked down the master branch. So no one can just go do a push to master directly. I have it locked down that the only way code can go into master is if we accept through a pull request. And so that's basically the pipeline there. Does anyone have any questions on that? Yeah.
How do you handle differences between apply and plan? Sometimes the plan doesn't go according to the apply doesn't go according to plan.
What would be an example of that?
If you screwed up your resources and the state doesn't quite match what you have in your config.
What would be the case where your state wouldn't match? The idea would be behind that everything is going through here, right? So your state should always be in sync. Like, the only way I can think of that is if someone went and changed a resource directly.
Yeah.
Yeah, I mean, it could happen for sure, but I mean, that would kind of be something outside of this. It wouldn't really be like an actions thing. Like, that would be where someone went into the UI. So that's where you'd have to put something else in place that, like, a regular user, like say myself, say you want to restrict me from going to delete stuff in cloud, where you would take away my permissions that I can't go in and click around. Anything I want to go do would have to be like at this level. So say I want to go make that Terraform change, or I want to go spin a new VM or change something, I have to go do it through code, and that'll only get approved if you allow me to, right? You're gonna restrict my privileges at the cloud level, so I can't just go in and do it that way.
And you're also using the one state as well, right?
Yeah.
If you ever try to import the random password generator, it doesn't work. So there's a resource called random.
Yeah, like the random integer or random string, yeah.
And the only way to do it is to update the state yourself if you want to import the existing resource that you've created before.
Yeah,
And
yeah.
that's the thing.
Yeah, no, for sure. Like, yeah, I know. Yeah, for sure. Importing state can definitely be. But in terms of trying to make sure the state is always matching, kind of being, I would follow the principle where it's not really an actions thing. It's more of on the outside being like, you're restricting my access into cloud, and only changes that me or any other developer will call ourselves has to be through the repo. It's kind of the whole thing that, like, everything lives in code, like our environment lives through code. So if I can go look at our repo and I see our Terraform code and I go read that, I know, without also looking at state or even looking at the cloud console, that kind of dictates what's provisioned in our cloud environment. Okay, any other questions? Kind of makes sense. Okay, so we'll just go through the actual repo. Start off by showing the Git workflows and the actual Terraform. There's two workflows. Like I mentioned, the first one is for pull requests, then the second one is to actually merge. So the Terraform one first is the pull request. So we have it listening on any pull request, so anytime I open one, this action will fire. And what it's doing is, we'll just go through it quickly, it's checking out the branch that it's currently on. It'll do a Terraform format. This is kind of just making sure that my Terraform code looks good. So for example, like Terraform complains if equal signs aren't lined up properly, to make sure that your curly braces are in line, stuff like that. It'll do a Terraform init first to make sure that the Terraform code can actually be initialized. We'll do some validations on it, and then we'll do a plan. So basically just kind of like the basic things you would want to check before even merging to master to make sure this code actually even works. And even so for someone like me, I don't even want to get notified if someone's working on the code and it can't even be properly planned out. So I'm passing a few secrets in here too. I think Ali touched on it earlier too. How it works is that I actually have GitHub token secrets, and this is for my actual repo itself. And then I also have a Google credentials because, like Daniel mentioned, I'm using remote state for everything. To do something like a Terraform init, where my state is saved on a GCP bucket, Terraform needs to be able to contact GCP and more specifically get to that bucket to check my state. So I have to pass the Google credentials pretty early, pretty much at the Terraform init level, to be able to go reach out to that state, go see what's different, and then I would definitely need it at the plan level, where I'm trying to see what's different and when that needs to be updated. And then the final action here I have is just sending me a Slack webhook, or sending me a Slack notification. So I have a channel here, and basically once this passes, so once it gets to a plan, it'll fire off a webhook to Slack, and I'll get a notification here saying that a PR on the website has been proposed. So we can just get right into actually doing it. So again, here's my bucket. Right now I just have an index.html. My images are stored in there, so I don't actually have an error.html, which is what I want to go and create. So we'll go and create it now. I have it already existing in my pages locally on the repository. So I'm just going to reference that with my Terraform code. So I'll go into the main.tf, and this is what my Terraform code looks like. Right, I have the provider because I'm writing to GCP. Here's my remote state. So I'm connecting to a GCS bucket located here. And then there's the path of where it's located. You can already see my index.html. So it's just a bucket object, and I can do basically just copy and paste it for error.html. So I can go ahead and do that. make sure I update everything. And one thing I'll do is to kind of show like how the validation works. So something like this really isn't valid in Terraform. So this just throw us an error. So say adding error, adding error.html. I'm going to create a new branch. I'll just call it error add and propose new file change. So it's going to open up a pull request. We're going to say create PR. And the pull request is created. So now we're going to see that GitHub Actions has now picked that up, and it's ready to, and in a second it's going to start actually running the action on this repo, which it's just done. So we can head over to details. Now it's going to say starting a workflow. So what it's basically doing, like Ali mentioned, it spins up a container, clones the repo in here, and just runs everything in this branch to verify that everything is okay. So you can see right here, it's pulling down the Terraform GitHub Actions plugin. Right, and then it's doing the Slack one as well because I've added the Slack integration, so it's doing the same thing it would have done for Terraform. And once it's done doing that, it's going to go ahead and start doing some of the Terraform validations, and we're going to see one failure right away. And the idea behind that is to show you that, like for someone like me who only is caring more about pull requests, I won't actually get the notification. Right, so we got our first error. So we got an error right here saying missing new line after argument, right? So on line 22, so that was where I put that curly brace on the same line. So now I can head over to the pull request, and now we can see that there's a failure, right? So it's kind of a nice indication right away saying like, hey, this failed, so it's nicer to see that you know, without actually having to dive deep into it, that you know there's something wrong. So let's go ahead and fix it. So we'll go back to the code, switch to our editor add branch, edit, and let's go put that on a new line. Fixing our typo. All right, we're going to commit directly to that error add branch. We don't need to create a new one. I spelled it and I put a typo in my commit message, but that's okay. Okay, so that's going to trigger another action, and we can see that. Let's refresh this. Okay, in the meantime, I'll just continue talking over it, and then once this picks it up, we'll go back to it. So the idea is now that it'll fully, once it starts going, we know that all of our syntax is okay. So by the end of it, what will happen is a Terraform plan will come out. I'll get a notification in my Slack saying that there's a new PR that's waiting. Oh, there we go. Finally, it's going. Okay.
Jacob,
Yeah.
by a Terraform plan comes out, do you save the plan to be applied later, or do you?
Yeah, so what's going to happen is, so I'll show you what happens is the Terraform plan then gets, so it doesn't get saved as like a text file that you could reuse again, just because once this is done running, that was in a separate container, and then when I go do the apply, it's going to spin up a new container and do the same thing again, pulling in, using my code, using my repo as that source. So it won't use that same plan that you outputted. It'll recreate a new Terraform plan and then use that when it's actually applying. But you are able to see what it will plan. Like it does shoot it out, and you can always reference it as long as you keep the pull request open. So I'll show you what it looks like.
So this initial step, you're just validating.
Yeah, so all this is just doing is just validating it and making sure that Terraform code is actually valid Terraform, and that it can actually be applied on my current infrastructure. Right. Okay. So the plan looks okay, and then I got a notification. Right. So it says a PR has been approved, or sorry, has been proposed. So now I can head over to my pull requests. Can go over here, and now I see a green check mark. And now for someone like me who's coming here just to administer this, I can go see there's a Terraform plan success, and I can show the output. So right here, this is the code that's going to be applied to my infrastructure. And all that's being changed is that we're now adding this new error.html.
So from an ops perspective, it's super easy. If you're an operations person, all you want to do is make sure that what he's asking for is compliant. That's all you have to worry about. You see that it's compliant. You accept pull request. and then the rest of the pipeline would go trigger each confirm.
Yeah, so the idea here is that I'm wearing two different hats, that I wouldn't actually be, I mean, I could be actually editing this and adding the error HTML, but the idea is that it's someone, like a developer, doing this code, like adding error.html or adding other change to the website, and then it's me coming in as someone who's more operations focused or more just focused on keeping the infrastructure of the website up to review something like this. So now that I've got notified, all the checks have passed, there's no conflicting with the base branch, I can go ahead and merge the pull request. So I can go ahead and confirm the merge. I won't delete the branch, I'll just leave it for now, just in case we need to go back and actually have a look at this. Head over to Actions again, and now we should see our Terraform apply kicking off. Now what this is going to go do, it's going to go use the master branch as the source to build our new infrastructure, and now that we have a new error.html, it's going to go ahead and upload that to my bucket, and then successfully I'll be able to see this new error page on my website. So I'll let that complete, and then I'll go over to the bucket, I'll refresh, I should see the error.html, and then I'll refresh the website and I'll see an error page. Okay, it's all good. I can go over here, refresh. I see now error.html. I can go ahead and do that. I now see an error 404 page. So something a little cleaner than just that ugly error message from before. Obviously this is still standing, but basically anything here just brings me there. Any questions on that? That's the demo of basically how to manage Terraform and infrastructure with GitHub Actions. Are there any questions anyone may have?
Do you know of a GitHub action that will check out the branch and test the merge commit as opposed to just the branch?
To test if the branch can be merged into master or something?
Not test the mergeability, but like test the merge, like the effect of like merging the commit into master, testing that. Well, I just know that to be the merge commit. I don't know what the feature is.
Are you talking in terms of Terraform specifically or just in general?
Just checking generally about GitHub Actions. It seems like it checks out the branch independent of master.
Right.
So you're testing the validity of the branch, but you're not testing the merge commit on master.
Right.
So GitHub action if for the merge commit.
Well, if you like, so for example,
so that's because you're using the actions checkout, right?
Right.
So in that case, you could write your own. I'm not sure if something exists already by GitHub.
Yeah, there might be. I'm not sure. But I mean, one second. See if I can pull up.
Now look at the actions, how it does
Here we
the
go.
checkout,
That's what I was looking for.
fork that, and use that as a base to manipulate the code to do whatever you're doing. The checkout one is usually the first time because it brings the repo into the machine.
Yeah.
But it's open, so you're welcome to, like, you can go into their code repo, fork it, see what the flow is, tweak it to what you need, and then make that your first action.
Cool.
So, super flexible because all the code is open, right? Yeah.
The other thing too with, and I lost the page now, but for example, once it's done doing the check, the other thing that GitHub will just do by default, it's going to check if the branch can actually even be merged into master based on like if there's any, like if master is ahead of that branch or something, if there's like some conflict, like that's GitHub like built, like that's built in already before actions checking.
Yeah, will prevent like conflict mergers, but there's also the feature where you can tell it you can't have a stale branch before you merge into master.
I think there is. I think I've seen something for stale branches. I'm pretty sure. I'll double check. But either way, we can take it up. But I recall seeing something for stale branches. It was one of the default actions. I'll check for you though.
The only reason I brought it up because like you render the plan as the comment on the pull request. But if someone merges another PR ahead of you,
oh right,
the plan could be different.
Yeah.
Like the delta of the plan could be different post merge. It's more of a race condition thing.
Yeah, I mean the idea too behind that is that I would make sure that it's like maybe like one person, like it could be one person merging as well, or maybe not one, but like a couple, and it's kind of like the idea would be that like 3 developers wouldn't also have the ability to go merge a pull, like go merge that branch, right? Because exactly like that could very well happen where if like me and you want to get something in the master, we also have the ability to merge. Then the other thing too is like I like adding is something like someone has to approve it, where it's like even if me, like if I want to merge to master, somebody else like you would have to, even for both admins, someone like you would have to make sure that mine's okay. So you'd have to approve it. And same thing with you. If you want to go merge something, I would have to go merge, right? So GitHub has the ability, or you can add approvers to the repo, and one of those, or the threshold, whatever you set as, has to go and approve that. So that would be, I guess, another way to help maybe solve the race condition, but it definitely could still happen. Any other questions? This repo is also publicly available too.
We'll all the code we've done today, we'll post it up, so you're free to pick it apart, use it, whichever.
Yeah. I think, I guess we'll send out the links, right?
Exactly.
Okay, cool. Yeah. So, if there's no other questions, that's my time. I'll be around, so if you have anything that comes up after, let me know. Thanks.
All right, so I'm going to be covering around how to roll out your own GitHub action. So a great example of what you were just talking about right now as well, if something like that doesn't exist on the marketplace, it's easy to go out and build your own, right? So a great example that I used for mine was a Terraform destroy. So believe it or not, destroy doesn't exist in the marketplace yet. HashiCorp has come out with init, validate, FMT, and plan and apply. But it hasn't come out with destroy yet. So for my example, what I did was I created my own, right? Publish on the marketplace and use it in a workflow, right? So this demo, essentially, it was hard to come up with a use case for this because in those 1,500 actions that exist in the marketplace, there's a ton of stuff in there, right? So we're thinking about brainstorming things around like what to do and like how do we get creative with this. So what we came around with was, you can see my speaker notes. So what we came up with was how to extend the GitHub API using Google Assistant, right? So in this demo, what I'm going to show you will be, I'll talk to Google Home appliance right here, provision some infrastructure in GCP using GitHub's API, which will involve opening and closing issues, and GitHub Actions will be triggered around that, right? So when an issue is opened, infrastructure will be provisioned in GCP. When an issue is closed, it will be destroyed. Right, so it's extended upon what Jacob was presenting as well, using Terraform, but it's going to go a little further and draw upon the GitHub API. Has anyone played around with GitHub API ever? I've coded a bunch with Python as well. It's really extendable. You can do a lot of stuff with it, right? So the first, so I'm using two custom actions essentially in my demo. The first one is going to be parsing the payload that's generated from Google Assistant, right? So when an issue is created from Assistant, which is hosted in GCP with Dialogflow, that's going to do an API call to GitHub. The first action is going to go ahead and parse the body of that issue and take the keywords that I'm going to talk to it, right? So it's going to ask me how many GCP instances I want. If I say 5, that's going to be the body of the issue, and it's going to take that, parse it, and put it in my code. And the second one that I have is the Terraform destroy. That's going to be essentially the destroy of the infrastructure, right? So that's going to be at the end. The parameters you see here, that's from my README. So a README is required every time you publish your own GitHub action. Mine takes an org name, a repo name. You can provide your own whatever. So a simple example of what it looks like in this case. Well, first of all, you can have your GitHub action coded in Docker. You can have a Docker file, or you can do a JavaScript. I went along with Docker. And what it essentially is an Alpine container that downloads Terraform, the binary in the container, and then it's running a shell script at entry point. And all that shell script is doing is just doing a git clone. My remote state is in GCS. It's pulling that state and just running Terraform destroy. That's it. The other thing you need for your own custom action is an actual action.yaml file. This essentially takes input of what you need to provide to that container, right? So this is going to involve the same thing as the org name, the repo name, and what it runs, right? And all these args are given at runtime as well. Any output you want to give to your container, that's defined here as well. Once you define this in your repo, you will have the option to release this, right? So same thing as how you package and release software on GitHub right now. You would do the same thing with which one the releases. You can version your release as well. Mine went up to 3. The other one I was testing went up to like 11, I think, or 8. So yeah, so you can have it as a tarball, you can have it as a zip file, and you can release it to the public, right? If you don't choose to do this, if you want to use your own repo, you can version by branch as well. So in this case, if I were to call this action for Terraform destroy actions, I would version it at v3. But if you don't want to release it, you would version it at master or whatever branch you have, right? So let me jump right into the demo. And I'll go over the code as well. So I've got Google Room here.
The mic's off right now. To turn the mic's back on.
So I tested this about 50 times last night, and it worked every single time. Now if it doesn't work, one of our guys already pointed out, hey, what if Google Assistant doesn't work? What's going to happen? I have my phone as backup, so I got a backup as well. So let's get this going. Hey Google, please talk to Arctiq GitHub Actions. Come on. Hold on. Hey Google, please talk to Arctiq GitHub Actions.
Getting the test version of Arctiq GitHub Actions.
Hi, how are you doing?
I'm good, how are you?
I am doing great. We've got a good crowd here today. Let them know microservices will solve all of their problems. Ha 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 ha. What can I do for you today?
Please run my GitHub action.
Okay, running your GitHub action now. How many GCP instances would you like?
77.
Come on, are you serious? Your lab admin is going to get really grumpy. Do you want to try again? Now, how many GCP instances would you like?
7.
Okay, building 7 GCP instances now. Please go to GitHub Actions to see the progress. Goodbye.
Okay. So if I refresh, you can see an issue just came up. That took like 2 seconds. So I have it listening on every issue I create. What that does is essentially trigger a new action. So you can see that the action for issue parser, provision with Terraform, I couldn't get located with names, it's a long name, but that fires up right away, right? And what that essentially contains are a mixture of one custom action and other actions provided by HashiCorp, right? So the first one that you see there, that's the GitHub one. I check out the branch. There's a little Terraform in it, Terraform plan, Terraform apply, and where's mine? Right here. So this is the custom action that I provided here, right? So the action issue parser, essentially all it's doing, it's taking the payload, parsing the data with sed. It's just a simple shell script, putting it into the body of the issue, and just taking that and provisioning instances in GCP. So if you take a look at the action issue parser, you would see that I have an action.yaml file here as well. Right? So it's the same thing that I had in the slides. You would keep this in your repo with the same Docker file. And what this would do, it would trigger an option to publish this release on Marketplace, right? So this is already published. So if I click on View on Marketplace now, you would see that this is available to the public to use, right? So out of the odd 1,500 ones, I've got 2 in there too. Feels pretty good. And you can use it, anyone can use it in the world, and you can keep track of that as well, right? So let's go back to the action and see what's happening here. Hope it's working. Oh, so it's completed. So I can go here, and you can see 7 GCP instances came up right away. So now when we were talking about it, we had a disclaimer, this is not an enterprise use case. I don't see anyone in the enterprise using Google Assistant to provision, but it's great for things like labbing it out, right? We have a workflow internally where we have a Ansible tower job every time it goes up and runs, like whenever we need a lab for anything development or anything like that. And it automatically goes and does that for you, right? So the second GitHub action that I have is essentially destroy, and that's going to get triggered by Google Assistant as well. So let's talk to this guy again. Hey Google, please talk to Arctiq GitHub Actions.
Sorry, I don't know how to help with that.
Hey Google, please talk to Arctiq GitHub Actions.
Sorry, I'm not sure how to help with that. I'm still learning.
One more time.
One more time? Yeah. Hey Google, talk to Arctiq GitHub Actions.
Let's get the test version of Arctiq GitHub Actions.
Hi, how are you doing?
Please destroy my GCP instances.
Okay, nuking your infrastructure. See y'all later.
Alright. So you can see one issue there. Refresh, the issue's closed. And that should trigger a Terraform destroy for you as well.
So, although not an enterprise use case, it just gives you the idea how extensible you can make this. It's just any API integration you're capable of leveraging with the platform, right? So.
Yes. So when I was playing around with this, I took it back to the first time I was learning Jenkins, and it's day and night. Like learning Groovy versus this is essentially like it's world apart. This is all human readable language. We don't need to learn anything. It's all YAML files. Anyone who here knows Kubernetes, Ansible, it'll take you like a couple of hours to ramp up on this. So this is going to go ahead and Terraform destroy everything. And you can see this is already getting triggered. Go back here. Yeah. So then this extends upon what you can do with it, right? So essentially, if you're getting a Docker file and you have a simple shell script to do something, then the world's your oyster, right? Like you can go and do everything, basically. I'm gonna wait till it destroys. Just do it short.
That's there.
Zero's gone. All right. Any questions? I think we're on Q&A as well right now.
The reluctance of the assistant to give you 77 instances was a budgetary constraint.
So this is the first thing we had was Tim's name. I don't know if you guys know Tim here. He's essentially, he admins our labs. So the first thing we had was that Tim's going to be really, really grumpy. So, but I went and changed it. But yeah, it's a budget thing. Right? We're on a version 77 instances in the cloud. And yeah, that's everything on. So, okay, perfect.
What's the cost like for
So I think there's 2,000 minutes for free. So everything we did, it's all on the free tier. Mike, actually, you can answer.
Yeah, sure. So Daniel, if you don't mind pulling up one of the pages, if that's okay, we just go to github.com/features/actions.
What was that, sorry?
Features/actions, and you just go right to the bottom. Yeah, so this is a page I went through, and at the very bottom, on the left, if it's open source, like everything we saw today, and it's public, it's free. On a pro plan, you get 3,000 for yourself. If you're on a team plan, 10,000, and then enterprise, you get 50. Now that said, it's consumption based, so if you use anything above and beyond that, the cost or the pricing is on the right there. And there is the option of self-hosted runner. So you've been mucking around with GCP stuff. If you want to run it on your own GCP infrastructure, you can. For some of my enterprise friends here, we are targeting potentially mid next year for a full GitHub Enterprise Actions runner in your on-premises network instance. Does that make sense? Does that answer that question? Okay.
Can runners also be set up within Kubernetes clusters?
TBD, right? So why I want to say TBD is long. The short answer is I don't know. Right now, the typical deployment is to be very similar to the GitHub Enterprise Server deployment options, which are VM right now and VPCs, right? So Azure, GCP, AWS, and an OVA, KVM, et cetera, et cetera. So whether or not we take the leap this time and go Docker, I don't know.
Sorry, maybe I'm misphrasing the question. I'm thinking in terms of having like a pod or some sort of software running inside our cluster that it modifies the cluster state.
Yeah, I don't know. Yeah, similar question. Thanks for the clarification, but that's being determined as we speak. Okay. Any other questions around this question?
Sorry.
Yeah, it's good.
No, there is an open source project that does just what you asked. It's called Action with a K.
Okay.
And then it runs Knative in, so it's compliant with GitHub Actions, and then it runs on your Kubernetes cluster.
Sweet. Thanks.
Yeah.
So for everyone here, if they want to revamp their pipeline to have Google Assistant running all their builds, what level of upgrades are required from the Arctiq team to come and do that?
So I'll gladly do it. For asking that. It requires a bit of JavaScript. I have a friend who's a really good front-end developer. I have his boss here in attendance. He helped me a bit with that, but it's all essentially JavaScript and Dialogflow, and you can just essentially call APIs wherever you want, right? But it's neat. You don't need Google Home for this, by the way. You can use your phone if you want to. So it's great for like just provisioning stuff on the go, destroying them, just ephemeral infrastructure, right? Just for development and things like that. Yeah.
One more on the more fun side, if you search for GitHub Actions dispense candy, I think it is, somebody wrote an action to dispense candy every time they commit code, right? So just another kind of fun thing that the community has been playing with.
I think you could probably hook it up to even the Domino's pizza delivery. Deliver pizza on Action.
Every time all the CI tests pass, you order pizza.
Solve lots of problems, right?
Hey, it's all about incentivization.
Have you had a chance to compare this to like Jenkins and Circle CI? Like, why would you, like, given this, why would you ever use Circle CI or Jenkins again?
So, like, for especially our customers, right? Not a lot of them are on the cloud. That's the first thing. So that's where Jenkins comes up. But for people that are using GitHub.com and are on the cloud, like, this is a no-brainer, right? Like, in terms of the level of effort you're going to get, you're going to make to get something up and running, compared to Jenkins, which you're going to maintain, upgrade, and all that stuff. This is all there for you, and it's all packaged up. You don't need to maintain any secrets, any keys, anything like that.
Its ease of use is truly its power. Like it just works. It's just plug and play.
Yeah. But it's hard to manage. Let's suppose they have 600 applications and they're dealing with 600 repositories or 600 workloads. That when it gets more complicated.
Yeah.
If it's like 10, 20, then it's different. But if it's like 500 applications, then you have to change all the 100 files for it.
Yeah. Yeah, for sure. And I don't think Jenkins solves that problem either, right? Like with 600 applications.
Like with the libraries, get the songs.
Yeah. So if there's no questions, we post our code for all the repos and community events as well, so you can check out Arctiq team on GitHub. They'll have everything. I plan to blog this as well. Release a blog, open it up, and if anyone wants to replicate this, they can.
We'll release the repo.
Yeah, and we'll release the repo as well. But yeah, thanks a lot for coming out. It was great. Do we have more tacos left? I don't know.
Oh yeah. So grab some drinks, hang out. We'll be around for a while. Feel free to chat. Yeah, thank you so much.
Yeah, thanks a lot, guys.